This Energy Code Compliance for Metal Building System webinar will focus in on the insulation prescriptive compliance options within the International Energy Conservation Code and ASHRAE Standard 90.1. We will have 4 parts to this webinar series. Part 1 will provide a broad introduction of the IECC and 90.1. These webinars are being hosted and presented by the Metal Building Manufacturers Association, and my name is Jay Johnson. I'm the Director of Architectural Services here at MBMA. The other webinars will get down into more information as relates to the insulation provisions. Specifically, Part 2 will focus in on the 2015 IECC, and then Part 3 will get into details within the 2013 edition of ASHRAE Standard 90.1. Lastly, the Part 4 will focus then in on the trade-off method, the UA trade-off method, and the information within the Department of Energy's ComCheck software as it relates to metal buildings. For Part 1, we'll review the development cycles of the IECC and 90.1. We'll provide a quick overview of the status of the Energy Code adoption across the United States. Quick review of the common terms and definitions used in the IECC and 90.1, such as the building envelope, climate zones, and space conditioning types. The primary reference documents are shown here, and these are updated and published every 3 years. The IECC could be recognized as the National Model Energy Code because most jurisdictions adopts the other I codes such as the International Building Code, International Residential Code, and so on. So municipalities and inspectors may be more familiar with the Energy Code, meaning the IECC. However, we want to point out that there is an optional compliance path within the IECC to get to 90.1, and that'll be of interest, especially if you have semi-heated spaces. The IECC is updated every 3 years, and the public can provide code proposals, and those are heard every 3 years. On the other hand, ASHRAE provides a venue for public comments to be submitted at any time and are heard and refined throughout the year. So it is under continuous maintenance. This slide shows a 2009 IECC, and it references the 2007 ASHRAE Standard 90.1. And both of these documents, as said earlier, are updated every 3 years. Such as a 2012 IECC, 2015 IECC, and the up-and-coming 2018 Energy Code, which should be out during the first quarter of 2018. And you'll notice the referenced ASHRAE standard, it refers back to the version previously published. So the 2012 will refer to the 2010 90.1. 2015 refers to the 2013 90.1. And the recently published 2016 edition of 90.1 was released in October of 2016. And we do know that this will be referenced in the 2018 IECC. And this will be important as I go through the ASHRAE 90.1 provisions. Even though we'll focus in on one particular version, the information learned within this webinar series can be transferred to other versions of the code. A little bit more about ASHRAE 90.1. As mentioned, it's on a continuous maintenance cycle. Once new proposals are approved, they are published as individual addendums, and the package addendas, I should say, are then published twice a year. So for instance, once they are published, then the next published hard copy version or electronic version of 90.1 will include all the addenda approved during the previous code cycle. However, once an addendum is approved, it refers to a particular version. So we'll take a look at addendum CP in one of these webinar sessions, and it updates the information contained within 90.1, the 2013 edition. Addendum CP introduces new metal building wall insulation systems and a new calculation procedure. So once a particular addendum is approved, it is published twice a year, and then municipalities can enforce them, or the code official or the architect or manufacturer may suggest to the code official that they take a look at a recently approved addendum for inclusion into a particular project. So this addendum CP was included within the 2016 standard, and we'll take a look at how it was included and when and why you may want to reference the 2016 standard, even though you're using an older version of ASHRAE 90.1. But I'm kind of getting ahead of myself. That will be covered in part 3 of the webinar series. The recently published Energy Design Guide for Metal Building Systems, the second edition, was released late 2016. The first edition was published back in 2010, and we recently updated to bring it up to date to today's latest codes and standards, addresses some of the MBMA research conducted as it relates to the energy code topic, and takes a look at other standards of interest and updates the provisions or the information included within the various chapters shown here on the screen. The publication is about 200 pages, so it is a wealth of information, and also we included the latest information on the green building codes, such as the International Green Construction Code, ASHRAE 189.1, High Performance Green Building Standard, and the LEED version 4 rating system, and how the credits may apply for a metal building project. Other information is included that is too much to cover in one webinar session. These webinar sessions in particular will draw from the information out of Chapter 3, 4, 5, and 6. So let's get into the status of energy code adoption across the United States. This map is taken out of the Department of Energy's website. If you go to energycodes.gov, you'll be able to navigate to this map. And I believe this map is interactive on the website, so you can click on a particular state to determine what particular version of the energy code is being used, or what municipalities are using various versions, or if there is a state-specific energy code. In general, this map highlights or color codes various states and makes note of which state is adopting, will be adopting, or currently enforcing a particular version. So as of October 2016, 9 states are either using the 2015 IECC or ASHRAE 90.1 2013. Or if they have a state-specific code that is equivalent to these 2 standards or more stringent. Moving on to the next slide, we have the 2012 IECC and its referenced 90.1 2010 version. So 16 states in blue utilize this version, and going back to the 09 IECC and 2007 90.1, 18 states. So it's pretty much split between the 09 IECC and the 2012 IECC, but more and more states are adopting the latest and greatest. The trend is that states typically wait for at least 2 code cycles to make a change. So we suspect some of these states shown in yellow will soon adopt the 2015 IECC or its reference 90.1 standard. So that's a quick snapshot. And then the states shown in white, roughly 13 states utilizes an older energy code or may not even have an energy code of interest. We are aware of 12 states that provide their own state-specific energy code, and we provided as shown in the red dots across this map. And more information is provided in the Energy Design Guide about the state-specific codes, more in a summary fashion and how it relates to the national provisions, the provisions of interest for a metal building project, and with direct hyperlinks to get to the latest energy code towards the state-specific sites. So in summary, we will focus on the 2015 IECC and 90.1 2013, but much of the information relates in general to the older codes, although they are likely less stringent in areas. So common terms, terminology, or just some common information, whether you use the IECC or 90.1, no matter which version, it's broken down into 4 major categories, sometimes known as chapters or simply as major sections, such as a building envelope, mechanical systems, service water heating, and power and lighting systems. For the purpose of our webinars, we'll continue to focus in on the building envelope. And what does that entail for a metal building? First off, let's have a brief overview on what would be considered a metal building in the energy codes. If you just simply have metal cladding, like metal wall panels and metal roof, and if you have metal studs, vertical studs, that would not be considered a metal building. A metal building in the energy codes assumes for the walls you have horizontal girts, whether they're C shapes or Z shaped, and they're spaced about 5 feet on center. And if you have purlins, such as C or Z shaped purlins spaced roughly 5 feet on center, and then you would have insulation that would either be compressed between the metal panel and top of the purlin, or for the walls, you would have insulation either compressed between the metal wall panel and the purlin, or it fills the cavity of the girts, which may or may not be compressed. As we get into the current energy codes, older energy codes always shown just a single layer of metal building insulation compressed between the metal wall panel and the girts, and maybe a single or a double layer compressed between the purlins and the roof panel. However, times have changed and the purlin and girt area has been filled. We refer to that as cavity-filled insulation. However, if you have a metal building that may look like this and you choose to include the traditional, steel studs vertically spaced, 16 to 24 inches on center, even though you have a metal building interior shell, you would use another category within the energy codes. Likewise for the roof. You may not use purlins, but you may use open joist or bar joists. And you may put insulation on top of a metal decking that sits on the bar joist. So that would be considered insulation entirely above the roof deck. And that's a different category, even though you may have primary rigid frames that would be tapered like this. For the interior metal building shell. And so things may look like a metal building, but you may have different features that would push you out of the metal building category within the energy codes. In general, whether you're in the IECC or 90.1, the building envelope would focus in on insulation provisions for all building types, whether you are wood, masonry, concrete tilled-up, metal buildings. So it addresses roofs, walls above grade, below grade, slabs on grade, and floors. The building envelope provisions also looks at cool roofs, thermally efficient windows, doors, and skylights, air barrier and air leakage provisions, and loading dock weather seals. And lastly, vestibules, which is included in all building types. So now let's take a look at the climate zone map, space conditioning types, and part 2 and 3 will look at the prescriptive method in greater detail in order to make your project energy code compliant. And then part 4 will get into the trade-off method. So first, let's take a look at this climate zone map, which is common to both the IECC and 90.1. So it's nice that they use the same map. So it's broken down into 8 climate zones, 7 of which are shown within the continental United States. And you get into climate zone 8 up into Alaska. So the colder the climate, obviously the higher the number. So less insulation requirements would be in climate zone 1 and 2 as they would be up in 6, 7, and 8. So where the energy codes reference the climate zone map, it refers back to the insulation provisions, fenestration, doors, space conditioning, air barriers, loading docks, cool roof, and HVAC provisions. One of the main differences between the IECC and 90.1 would be the space conditioning types and how it is defined. The IECC does not give you any credit or any reduction in insulation provisions if you're not really heating or cooling it. I should say really heating it to a high level. If you have a semi-heated space or a warehouse space that you really just want to make it comfortable for its occupants, I always say right around 50 degrees Fahrenheit, or if you just want to keep the materials from within the building from freezing, that could be considered a semi-heated space. So you would have less insulation requirements since you're really not you're not required to keep the building energy efficient with a high level of insulation or a higher level of thermally efficient windows, doors, or skylights. So even if you have a space that could be considered semi-heated and you're moving along within the IECC, you would need to insulate it to the higher levels. I already mentioned some spaces that would be or could have semi-heated spaces, such as agricultural buildings, warehouse buildings, maybe even aircraft hangars. However, even those types could be conditioned, just depending on the end use. Obviously, buildings such as healthcare, restaurants, churches, office spaces would be fully conditioned. But you may have a split case condition where your office is fully conditioned and your warehouse is semi-heated. So for that case, we recommend you investigate the provisions within ASHRAE 90.1. That way you could meet the fully conditioned space for the office area and then use the semi-heated space provisions for the warehouse area. A little bit more about space conditioning types and how they're defined. And the IECC keeps it simple. In fact, anything less than 3.4 BTUs per hour per square foot of heating capacity of the HVAC system would be considered a low energy building. And then you are exempt from the building envelope provisions. However, you still need to meet the mechanical, service water, and electrical provisions. For fully conditioned spaces, you have it defined as either being heated or cooled. So anything greater than a 3.4 or equal to 3.4 BTUs per hour per square foot. It's as simple as that. However, you get to 90.1, they have a similar category called non-conditioned, which meets or aligns with the low energy category provision of the IECC. But then it breaks down the heated and cooled space provisions for fully conditioned space. Cooled is meaning that if you are using an air conditioning system with an output of anything greater than 5 BTUs per hour per square foot. If one were energy modeling this, it assumes anything around the 75 degree Fahrenheit threshold. Heated, just to keep the occupants comfortable at around 70 or greater. The heated space is broken down by climate zones and still utilizes the BTUs per hour per square foot, but it varies based on where you are in the country. So you would be considered conditioned if you're anything greater than 5 BTUs per hour in climate zone 1 and 2. But that would not be the case if you were in climate zone 6. You would have to be above 20. And then semi-heated space provisions comes in. So anything greater than 3.4, but less than the heated space threshold per climate zone. So for climate zone 6, you could be considered semi-heated between 3.4 and 20. The provisions within 90.1 requires the municipality to approve to design your building as semi-heated in climate zones 4 through 8. So just be aware of that. The compliance methods within IECC and 90.1 in general are outlined on this slide. However, individual provisions will vary between one version to the next, between the IECC and 90.1. But from a high-level view, the prescriptive method, the trade-off method, and the performance method are three distinct paths one can take. The prescriptive method is the easiest to comply with because it basically outlines what a building needs to do as far as for the building envelope. So it sets specific requirements for insulation, windows, doors, and skylights. Does include prescriptive air leakage provisions. And as far as the insulation, it gives you the option to use the insulation R value method, where it outlines specific R values and how many layers of insulation and types of insulation to use. Or it gives you a more flexibility with the U factor method. And we'll get into that in part 2 and part 3 of the webinar series. The trade-off method, the 2015 IECC introduced UA trade-off calculations that basically does the same in a simpler manner than the Department of Energy's ComCheck software. Both of these options provides you with the U factor substitution, way to possibly put in better window, doors, and skylights that are more thermally efficient. You may want to investigate putting in less insulation into the roof or the wall. Or vice versa, you may want to put less insulation in the wall and put more in the roof. However, that is becoming more challenging to do with the latest energy codes because of the amount of insulation or the U factor that is required. So part 4, we'll get into the trade-off method. The performance method is much more involved. One would typically hire an energy code consultant that uses proprietary, sometimes costly software programs, and it provides you also a trade-off approach, but it takes a look at trading off envelope, mechanical, and the electrical lighting, whereas the ComCheck software just primarily allows you to trade off the building envelope provisions. So we'll focus more in on the R value and U factor method regarding insulation in the upcoming webinar in part 2 for the 2015 IECC and part 3 ASHRAE Standard 90.1. If you have any questions as you review these webinars, or if you have a particular project question or state-specific energy code question, feel free to contact me. The easiest way is to go to our website at mbma.com, navigate to the Contact Us form, enter in your information and your question, and we will get back to you in a timely manner. Or feel free to contact us directly with the phone number provided on the website.